Welcome, my name's Andy, and if we have aspirations to be natives to the cloud or natives on the cloud, standing on the summit of the cloud, being native, that sort of stuff, we need to have a talk about microservices. So microservices, they're the best of architectures, they're also the worst of architectures, as they say in the classics. So, best of architectures, worst of architectures, but you could make that statement around pretty much any architectural style you choose. Because when you choose a style, you hopefully benefit from the upside of that particular style you choose, but you also need to be aware of the downsides and you need to deal with those consequences. Every style has its own unique little kind of set of trade-offs you need to be aware of. And in essence, when you're doing this, microservices or otherwise, you're basically making a Faustian pact with the architectural devil, this gentleman here. And that's what I want to talk about today, the pact rather than the devil. I want to talk about one particular trade-off which is particularly relevant when we're talking about microservices and distributed computing in general, but microservices in particular. I'm going to talk about a bunch of approaches which you can, you should, and indeed many teams do use to try and mitigate the risks of that trade-off. I'm going to spend a fair chunk of time looking at some research I did with teams that are in that situation and are using those approaches. And then time permitting, I'll have a few words of wisdom at the very end. So let's start with the trade-off. And as the title of my talk kind of gave away, it's got something to do with consistency. And specifically, it's the trade-off between autonomy and consistency that we have when we're working with microservices. Autonomy, delivery team autonomy, is one of the biggest advantages that we get. And it comes about in many forms. You get a lot of power back as a delivery team building microservices. You get power to do things like choose the tech stack for the service you're building, both the production tech stack and the testing tech stack, all that sort of stuff, somewhat independently of similar decisions being made before, during, and after by other teams building other services. You have the power to be able to scale your service independently at runtime for basically the same reasons. You can do things like safely refactor your database because it's your database. You can trust that there's no other systems that have their technical tendrils kind of tucked into your schema because you and you alone own that database. And ultimately, this power kind of manifests in the ability for teams to go quickly. That's the principal benefit. And for people sitting out in the audience, building in a microservices kind of approach now, hopefully you're seeing one of those benefits. And the benefits are all good and the benefits are fine and dandy, but I do want to talk about the other side of that, which is consistency. Because when we went from building predominantly monolithic systems to building predominantly distributed microservice systems, consistency got hard. We originally had that binding force of having a single code base in primarily a single code stack. So getting consistency around things was actually, relatively speaking, easy to do. Now we're isolating ourselves by design in terms of the code base and possibly in terms of the teams. So some things which used to be easy to get done in a consistent fashion are now actually really hard. Now, when I say consistency for the rest of this presentation, I'm not talking about data consistency, I'm talking about consistency of implementation of things which are important to get done right across multiple services. So this is as comprehensive a list as I can find of architectural illities. Drag this straight from Wikipedia, don't try and read too much of it. The bolding is my editorial addition to that. They are the illities or the non-functional requirements or the cross-functional requirements which I think you really need to pay attention to if you're building microservices. They're the things that I think we need to be consistent about. Some specific examples of that, and this was mentioned earlier today as well, logging. It'd be nice if from service to service to service, we're logging the same way. If we're structuring our logs, that they're in the same structure. First of all, if we've got timestamps, that would be a good starter. If timestamps in the same time zone, can we tell what time zone the timestamps are actually in? I see nodding heads. People have had to debug those issues in the past, I can tell. Rolling policies, all that sort of stuff. It'd be good to get that really consistent. It'd be nice to be able to deal with security in a consistent way as well. If we're using a very kind of commonly depended upon library, and I'm just going to pick Lodash from the JavaScript world because it's a good culprit in this particular respect, and many of our services are using Lodash, when the next vulnerability is raised against Lodash, the last one was in July, the next one's could be now, how do we work out exactly which of our fleet of services is dependent on that library, and how do we make sure those patches get into production as quickly as possible? Rather than just waiting on the natural release cadence of the individual teams for the next time they happily get that service deployed. If we're talking to external services, it'd be nice to have a consistent approach to resilience. Are we using bulkheads? Are we using circuit breakers? How are we configuring our our timeouts, our rollback, our retry policy? All those things that would make Michael Nygaard kind of smile, the guy behind the release books. Now, I've been saying it's been nice to have for many of these things, but it's where the table stakes of this game is kind of well above nice to have. These things are should have or must have in many cases. And ultimately the question is, what price are we willing to pay for that autonomy? We get the autonomy out of the box, we benefit from that by building microservices using that particular style. Our teams have a lot of power, they can move relatively quickly. How do we compensate with the problems or the potential risk of being harder and harder to get things done consistently? And which individuals or which roles in organisations care about those sort of things? Usually it's the architects or people who have architect in their title. They'll send tersely worded emails or copiously documented requirement specs or reference architectures expressing their intent about wanting to get all these things done consistently. Your mileage may vary. In my experience, none of these things are particularly influential when it comes to trying to convince delivery teams to take that sort of stuff seriously. Production incidents, on the other hand, very, very powerful tool. All it needs is a couple of production incidents at the wrong time of the morning to have to pull in people from a couple of different delivery teams to work out where did this problem come from, where did it go to, how do we fix it? And all of a sudden you get a bit more naturally occurring empathy between and across teams for wanting to get things done in a consistent fashion. All right, so enough about the trade-off. Let's look at the approaches, because there are ways that are more proactive than just waiting for those 3 o'clock PagerDuty calls to come in. And there's 6 of them I'm going to talk about. Now, none of them are microservices specific. A lot of them are kind of closely coupled with the idea of doing distributed computing better, and if we're building microservices by our very nature, we are building distributed systems. Some of them predate microservices by a long way, but all of them are quite useful in various combinations to be able to help get some of this consistency. And you'll know most of these terms. One of the terms I've been slightly fast and loose with some labeling, and I'll get to that, but the rest of them we should be very familiar with, including people who went to some of the workshops yesterday as well. So I want to talk about coding standards, good old-fashioned coding standards. I want to talk about service templates. I want to talk about client libraries. I want to talk about platform libraries, which is the term I'll take a bit of time to describe. I want to talk about service mesh, only a little bit because we had a great discussion on service mesh just before. And I want to talk about container orchestration as well. Coding standards, very quickly, it's on a wall or it's on a whiteboard or it's on an internal wiki or a Confluence page or something like that, written down statements around the thing that the team or teams building services want to get done in a consistent way. They effectively form a loose social contract so that the teams that are building those services hopefully build those with the coding standards or the design patterns in mind. Okay. So lightweight, old as the hills, reasonably effective. Service templates. You may know this by a different term. Some people call this bootstraps or starter services or base services. The implementation's largely the same. This term comes from the Building Microservices book by Sam Newman. The idea is you have a static code base in a repository somewhere that's like a Hello World 1 example, Hello World 101 example for how we build a service in this particular environment, including all the configuration and all the opinions codified about the way we want to do things, hopefully in a consistent fashion. So teams clone and then start their new services from that template, and then in an ideal world, the DNA from that template flows through into those services and we get consistency that way. All that localization, all that opinion and that configuration is going to happen within a team or an area or an organization, but you scratch the surface of most of these templates and you'll find open source software generally at its heart. Spring Boot's, I work a lot in the JVM space, so a lot of my examples are going to be Java-based or JVM-based. Spring Boot's the 800-pound gorilla in this particular world. They have a subcomponent called Actuator, which gives you a whole bunch of endpoints for free, more or less for free. Certainly the naming, in many cases the implementation as well. So if your services are based off something like a Spring Boot Actuator template, at an operational API point of view, they are immediately very, very consistent, which is a good thing. Client libraries, if I'm working on service A, calling service B, 9 times out of 10, 19 times out of 20, that's going to be JSON over HTTP because that's how we do things. To be honest, I'm too old to write more HTTP code. I've done that too many times. I would like someone to solve that problem for me, give me a nice little abstraction around that call so I don't have to worry about any of the HTTP-ness of it. And I want that abstraction to be in a language of my choice. If I'm being a Java dinosaur, I want that to be a Java-based library. If I'm being a Node hipster, I want that to be a JavaScript-based library. I don't want to care about the response codes. I don't want to care about how I form the query string. I don't want to care about how I kind of marshal and unmarshal the payload. I want that problem to be solved and all abstracted away, coupled up nicely in that library. In an ideal world, I want that library to be written by the producers of Service B, so that when other people call it, they can share that love as well. AWS does this quite well. So the AWS API, for those of you who haven't used Amazon, is, again, JSON over HTTP, I think. I say I think because I haven't used it directly for so long. They have all the colours of the language rainbow versions of their SDK. So pretty much any language you probably want to be using, you don't have to step outside your comfort zone of that language to talk to Amazon. Platform libraries. Okay. So this is a very special, well, a slightly specialised version of the general notion of a library. We abstract a possible single concept, reusable concept into a module of code. We call it a library. In this particular case, the things that we're abstracting away are things we want to get consistent across services again. That's all I mean by a platform library. And usually they're kind of bundled up using whatever appropriate mechanism is right for the environment that we're in. Service mesh, I won't linger on this for too long. It's nice that we've gone beyond that kind of chaotic, anarchic, heady days of 2017 where we had services calling other services willy-nilly. Thankfully now with service mesh, all our services are now kind of upwardly mobile. They're affluent. They all can afford their own little personal assistants that we call proxies or sidecars. Never need to talk to each other directly again. And kind of flippant description aside, there is a lot of benefits that were touched on previously today about the things that you get out of the box using stuff like Istio in terms of consistency across your fleet of services. Final stop on the approaches tour is just container orchestration, and obviously lots of technical details. I reckon most of you have a pretty good handle on how this stuff works. Conceptually, I just think of it as going from this to this, okay? Okay. Probably a few more details I've missed, maybe some boxes I've missed, but that's basically the idea. All right, so research. I am very lucky because as a ThoughtWorks employee, I have access to our network of engineers. We have about 3,000 or so, give or take, around the world. And I know we do a lot of microservices. I know we spend a lot of time building microservices. So I sent out a Google form, Google spreadsheet survey, trying to reach as many of our teams building microservices as possible, asking them how they go about using those 6 approaches that we just spoke about and kind of what their findings were. And that's kind of basis the rest of the talk. Now, there were 6 questions I really wanted to get answers to through this survey. I wanted to understand primarily what approaches are they using? Are there any particular combinations of approaches that they use? Are there approaches that flock together more often than not? What are the common tools for each approach? A couple of questions around scale. Does the number of services and the number of teams that they are building have any impact on the approaches they're using? And then finally, which ones are causing them the most problems? And we'll address each of these in turn. A little bit of context here. So I got 30 responses. I was kind of hoping for 50. I only got 30. To be honest, as my accent suggests, I'm from the West Island, so most of the responses came from there. If you scratch under the surface, you'll probably find that all the ones that are outside of Australia are probably expat Australian thought workers that I just virtually nudged through the interwebs to get them to respond. Next time I'm going to send this out from Martin Fowler's email address and I'll get 300, but I'm not bitter about that at all. These is the breakdown of services versus teams. So this is the data that I got. I asked them, how many services are you responsible for in the team that you're responding on behalf of? And how many teams are working in that same area building services? Okay. So not teams in the other part of the organisation where the services are never going to meet, but how many other teams are collectively building services as part of a single solution? You can see that caterpillar down the bottom left is all the single teams doing a number of services, and there's a reasonable scattering beyond that as well. Now I have, in full disclosure, I've omitted one data point from this graph because it made the visualisation of this too difficult, and it basically squashed all of this down into too small an area to read. And if you kind of crane your necks up and to the right, to the very, very top of that slide, we have a statistical outlier, which is also the closest approximation I can find to software engineering hell, to be perfectly honest. 170 services, 30 teams. I've included their data in all the other aggregate information I'm going to show, but it's out of this diagram just from a scaling point of view. Good luck to them. Okay, if you're kind of curious to know on average, how many services each of these teams are responsible for, then it's 4 and a bit. Okay? And I've sorted this, which is why that graph kind of goes up in that particular direction. But you might want to think about that, compare that to the environments and the teams that you're working around, how that number fits. The most common one was 1, the middle is 2 and a bit, but 4 and a bit was the average. Now, I do need to take a bit of time to talk about that other outlier on your extreme right hand there, that 23. I spoke to the tech lead who submitted this data because I thought it might have been a data entry and someone had fat-fingered it, but no, it was indeed one team, 23 services. He said that had they had their chance to do it again, it probably would have been about 7 or 8. They kind of sliced their services way too thinly the first time, which is a very common problem. If you don't understand the domain and how the domain moves, you can often either get your services too big or too small. They went too small. But I've left that data in there as it came in as 23. It brings the average down to a little bit below 4. Doesn't do much of a change. All right, what are the findings? So, what approaches are the teams using? Now, the important point here, none of the questions on my survey were mandatory. I didn't want people to drop out because they had too many red asterisks next to the questions. So I don't get a full 30 responses to each of these. But most of the teams are using coding standards of some form. So 26 responses, 21 of those are using coding standards. The blue segment there is teams that are planning on using coding standards at some point as well. Service templates, 21 out of 30 there. We do have a chunk of teams that aren't using service templates. One of those smaller segments there, the red or the yellow, is actually a team that, or actually an area that started using them and then stopped using them deliberately. And there'll be reasons that shine some light on that towards the end of the talk. Client libraries was a real split, 50-50 from the responses I got. And that kind of shows up later on too. Platform libraries, 16 out of 22. Service mesh, unfortunately, not the most popular kid in the sandpit at the moment. Does get to shine a little bit later on, but not that many teams at this point in time using service mesh. On the other hand, container orchestration, everyone loves the Kubernetes and the others, but it's mostly Kubernetes. All right, popular combinations. There are several. Okay. There's no real head and shoulders above the rest, single golden silver bullet combination of these things that works for all those teams. But there are 4 sets of approaches that occurred more than once. Okay. So those ones there, either 3 out of 30 responses, so 10%, or a little bit more than that, were using those combinations of approaches together. Every other combination that you can't see there, including none of them and all of them, either occurred once or not at all, so I didn't list it here. And the common thread I think you can see through that is the use of coding standards, service templates, and container orchestration together. All right, most common tools for each approach, and I think we've touched on most of these tools in presentations up until today anyway, up until now anyway. 75% of the teams using service templates, using Spring Boot. Client libraries, nothing popular at all. And there are lots of onesies in those answers, nothing more than a single occurrence. Platform library, again, Spring Boot, not as dominant, but certainly still there. We do work organisationally across more than just the JVM, but we obviously do a lot of JVM stuff, so there's a lot of JVM kind of bias in some of these results. And Spring Boot, for those of you who know, is a very broad church or a big kitchen sink, depending on how you want to describe it, and there are lots of little sub-projects that can certainly be used to create platform templates from Spring Boot components. Service mesh, again, not popularly used, but where it is used, it's almost 3/4 of the time Istio in some form, kind of managed self-hosted Istio. Container orchestrators, this is the only one which had a number 1 and a clear number 2 as well. 2/3 of the teams using Kubernetes in some form, and almost 1/4 of the teams using Amazon ECS. Okay. All right, again, interesting to see just within your own minds whether this is consistent with what you see in the areas you work in as well. Does the number of services impact the approaches used? So the way I tried to answer this, and I'm not a mathematician, not a statistician at all, is I split the responses into 2 equal-sized buckets. If you're building 7 or less services, you're in the lower bucket. If you're building more than 7 services, you're in the upper bucket. And doing that split and then, again, looking for common groupings of approaches, there were a couple there which were common, well, there's one that was common to both. There are a couple which were common in a single bucket and not the other, but again, not a really strong trend there. 2 out of 15 or 3 out of 15 was the best that we could get. So not a strong link there, but I could tell between number of services and approaches. Same approach for number of teams. To get that 50-50 split, one team, all the one team responses went into the bottom bucket, all the other, including the 30 teams, went into the top bucket. Slightly broader spread of approaches being used, but again, not back even less significance in terms of any sort of correlation between those approaches and the size of the number of teams, which is a bit disappointing. The question I did ask, and in retrospect I would have, if I get a chance to do this again, is to try and get some sense of how mature and how long-lived these teams have been. I didn't ask that question, and that would have been, again, in retrospect, a really useful extra data point for me to try and correlate some of these choices. All right. Which approaches are the most problematic? Up until now, we've been dealing with all the quantitative data. I did ask a qualitative question. What are your opinions on how these things are going? And I'm basically going to pull lots of quotes through into these sections, one approach at a time. I've left the quotes as they are. I might have shortened them for brevity, and I've emphasised certain parts, but the quotes are as they came into me. So when it comes to coding standards, we're building documentation, and most documentation by its very nature is detached from the thing that it's documenting. So that inevitability of drift between the reality as documented and the reality as implemented is there. So that's something we need to deal with any of those things. Documents need to be communicated. People need to be aware that they're there for them to actually make sense and to be used. And then finally, there is a risk that you become too prescriptive in these things. Remember, the big benefits of microservices that I spoke at the start was the autonomy that teams get. If we make these standards too prescriptive, too thou shalt do A and then B and then C, but not before D, then you're going to take away that sense of autonomy and you're going to lose a lot of the value add. Service templates. Some teams have it, some don't. We've got a couple of responses along those lines, where the service templates were there, but they weren't being used broadly. They were being used in pockets rather than everywhere. And again, the value starts to diminish if we're not using this to get that consistency in all the services that we're building. This is a big problem. When you have a service template, which is, again, is in essence kind of a form of documentation, if you clone that repository and then start building from it, you've detached yourself from that original repository. If there are changes to that service template, what's the migration path? What's the upgrade path? That's a software product evolution problem, and it's a difficult one. And it's a very difficult one for many organizations if they haven't invested a lot of time into this. Client libraries got a pass again. I didn't have a lot of strong data about client libraries. No one said anything particularly problematic about them. Platform libraries, effectively a shared code. So when we have shared code and we have to make changes to that shared code, kind of similar to the service template one, how do we go about getting those changes out there? How do we propagate those changes through to all the services that are using that shared code? How do we maintain ownership and curation of those libraries? Probably the biggest problem that I've certainly seen personally, let alone come through from this research. Who owns these shared libraries? Who makes sure they're correct? Again, how do we make sure, what's the roadmap and the vision for those libraries? What happens if we do have one of those Lodash style vulnerabilities that I spoke about? How do we quickly get those patches out into production? And then finally, I kind of feel for this particular person, whoever they are, they can see the benefit of introducing a shared library or introducing a platform library to get some consistency, but they understand the downside. They understand that they are going to be coupling teams that perhaps haven't been coupled by doing so, and they're really feeling that tension of should I, shouldn't I? Service mesh. I'm not quite sure whether this is a thinly veiled stab at Istio as much as it is one at AppMesh. I'm willing to give it a benefit of the doubt. That's the only thing that kind of came out from a service mesh point of view. And there's really nothing from a container orchestration. No common thread there that was kind of worthy talking about. All right, there are a bunch around the whole topic in general. Teams always talking about consistency versus autonomy, okay, and not having clear resolution for that. How do we get a good way to solve that code reuse issue? What happens if you've left it go for so long that The horse is bolted, the stable door is shut, the milk is spilt, metaphor, metaphor, metaphor. How do we go about trying to recoup some of those problems if we've left it too long? So where does that leave us? Well, it left me trying to do one thing. I tried to fill out this chart here, this matrix. I tried to kind of cross-match all of the 6 approaches with all of the however many ilities there are that I bolded back early on in that slide to work out which ones applied best in each situation. And I started from the bottom up because I knew enough about Kubernetes, I knew enough about Istio and service mesh type tools that I could fill out those bottom 2 rows reasonably confidently, because they're products and you may or may not choose to use all the things they give you, but what they give you is clearly defined. And that bit was easy. And then I got completely lost. I had no ability to fill out the rest of the columns. And the answer is obvious when you think about it. Which platform libraries you use, which client libraries you use, how you put together your service templates and what coding standards you have is such an individualistic, localized thing that you can't extrapolate or even make any sensible assumptions around what boxes those other things should be ticking. Which leads me to my final comments. If this is something that you're interested in and or something that you're being hurt by at the moment, these are my final thoughts. Start planning for how to deal with this consistency early on, but don't start doing anything about it on day one. You don't want to prematurely optimize from a tooling point of view, but you do probably want to have your tech leads or whoever the responsible people are talking about these things from very early on, especially if you think you're going to be building services at scale. Shared code, which might indeed help through libraries, platform libraries in particular, does introduce coupling. So don't not do it because you have coupling there, but just be aware that you still want to get a net benefit and that the problems that the shared code, the platform libraries are resolving is indeed greater than possibly the drag and the lack of autonomy that coupling is going to introduce. Ownership of shared code, not a solved problem. A few of my clients have platform teams that are solely tasked around building some of that shared code, but that again, I've not seen done well enough, often enough to know that that is a very easy path to go down. I think there's still some patterns to emerge around the way those teams work and the way organizations invest in them. My recommendation would be leverage service mesh and container orchestrators for as much of that stuff as you possibly can, if you can. Yes, it's shared code again, but it's shared code that is being backed by some reasonably large organizations and those tools are maturing quite well, and it's not someone inside your team that needs to take care of it. And then use those other approaches to fill in the gaps where you can see the gaps coming. Thank you very much. I hope there's some food for thought for everyone there. Do we have time for a question? We have time for 2 questions, or that was a rude sign. I'm not sure which way his hand was facing. Yep, down the front.
Yeah, one comment. I thought it was interesting the response about the number of services per approach, and seeing that the previous presentations on mesh and benefits, but yet it being skewed to the least amount of services. Did you notice that, or did you ask them why?
So which one in particular? The number of services? Yep. Yep.
With the service counts.
Yep.
And then
yep.
the technology used, and either I misread it.
Right.
Surprisingly, the lower the services, the more likely in this limited amount of survey respondents were actually to be using mesh. And it would seem like the opposite would be.
Yeah, my gut feel, and I didn't get a chance to speak to all the tech leads, the ones that I kind of know because they're geographically close to me, there are some organizations where the use of mesh hasn't got past their internal governance process. So the ability to even use it, whether you want to or not, is not there. That's certainly talking to a couple of those. I don't want to necessarily extrapolate that as an answer for all of them. I think it's also, from a marketplace point of view, the maturity of the technology. We work a lot in enterprises as well, and they're probably slightly laggy in terms of catching up with some of the more modern tech. I think it's probably contributing to it as well. I think if I was to do this again in 12 months, I suspect the service mesh numbers will go up quite significantly. Yeah. No? Yes, gentleman in the blue top. Yeah, so the question is, what is the general size of the teams for the services? And again, I did not collect that data. From a kind of ThoughtWorks cultural point of view, our teams tend to max out with a little bit of variation around 8 to 10 developers, generally speaking. Now, there'll be some outliers to that as well, but that would be, I would think, a reasonably comfortable average. We might have some that are smaller than that, but we don't tend to like to have teams with more engineers than that. And there'll be other capabilities around that engineering group as well. But from an actual people writing code, probably about 8 to 10. All right, and I think I've done my limit. Okay, thank you very much, folks.